Hello everyone. Welcome to the Introduction to ASPEN Plus with me, Dr. Pantisa Limlamtong from Kasetsart University. Today, I'm going to introduce you what ASPEN Plus is and how we can use it to model process flow sheets and simulate the chemical engineering case study. So, let's get started. First of all, before getting to know about ASPEN Plus, you should be able to answer this question. What is modeling and simulation? In chemical engineering, a mathematical model is the most common tool used to represent the physical-chemical behavior of a real process. In this context, modeling therefore refers to all actions involved in developing and validating such a model, whereas simulation refers to the use of the developed model to study the behavior of the system or to evaluate alternative strategies for the development or the operation of the system. In order to perform modeling and simulation of chemical processes, there are two main types of models need to be specified. First, you need to define properties methods to develop thermodynamic models to represent the physical properties of the components and the mixture in the process. Second, you need to define the unit operations in the process and select the unit operations model to represent the characteristics and behavior of each unit operation, or chemical synthesis. These two models are often built in the flowsheet simulators. Therefore, users do not usually need to perform the modeling step, but just simply choose the ready-to-use models. These selected models, together with the specification of input variables, process design variables, and operating conditions, will be further used to create the process simulation. In order to investigate the system behavior. So, what is ASPEN Plus? ASPEN is an acronym of Advanced System for Process Engineering. ASPEN Plus is a powerful process simulator developed by ASPEN Tech, which is used to quantitatively model partial or entire chemical processing plants, which allows to understand and predict the behavior of a process by using basic engineering relationships such as mass and energy balances, phase and chemical equilibriums, and reaction stoichiometry and kinetic data. ASPEN Plus also has a large chemical database with best-in-class thermophysical properties built in such as NIST database, so the model accuracy can be ensured. ASPEN Plus is developed based on the flowsheet simulation. In other words, it is essentially a simulation construct from a process flow diagram or PFD. If ones are not familiar with this term, let me introduce you some background about three types of diagram commonly used in chemical and process engineering, starting from the simplest one to the most detailed one. First, a block flow diagram, or BFD. BFD is a drawing of the chemical processes used to simplify and understand the basic structure of a system. It is a simplest form of the flow diagrams used in industry. Blocks in a BFD can represent anything from a single piece of equipment to an entire plant. Second, a process flow diagram or PFD. This diagram indicates the general flow of plant processes and equipment. The PFD displays the relationship between major equipment of the plant's facility and does not show minor details such as piping details and designations. Another commonly used term for a PFD is a flowsheet. And the last one is a piping and instrument diagram of P&ID. It is a detailed diagram in the process industry which shows the piping and process equipment together with the instrumentation and control devices. As mentioned earlier that ASPEN Plus is developed based on a flowsheet simulation. This means that the simulation of an entire chemical process starting from the raw material to the final finished product is symbolically represented by different icons, where each icon stands for a unit operation, chemical process, input and output material stream, and input and output energy stream. In terms of ASPEN Plus flowsheet notation, there will be a block icon and a stream icon. Flowsheet simulators like ASPEN Plus enable us to do many tasks such as conduct what-if tests. For example, what the reactor diameter will be if the reactant flow rate increase double. Or to perform design specification checks. For example, design plant configuration to achieve product specification. Or to identify savings opportunities, both in terms of energy and cost. For example, identify an opportunity to reduce greenhouse gas emission by improving equipment design configurations. Or to carry out the bottlenecking of constricting parts of a process studies. This is to identify the bottleneck part of the process for further improvements or modifications. Or to perform sensitivity analysis, which is the study of how output variables of a system are affected based on changes in input variables. And to run optimization investigations, which aims to obtain the most optimal solutions to be implemented in practice for any decision-making task. With the task mentioned earlier, the process simulation therefore has several advantages. It helps reduce plant design time, especially for a large process, since it allows the process designer to quickly test various plant configurations. It helps design better plants with higher performance and more efficient operation, and also increase profitability of the existing plants by performing economic evaluation to realize savings in the process design. The flowsheet simulation is also useful throughout the entire life cycle of the process, from research and development through process design to production. In ASPEN Plus, the standard modeling approach is sequential modular, or SM. The SM strategy solves individual unit model or block in a sequence, where the output streams of a unit model are evaluated based on the input streams and design parameters. When there are recycled streams exists, flowsheet iteration is required. Although SM is effective for many types of simulations, it can be very time-consuming for certain types of problems. For example, processes with a large number of recycle loops. Another alternative strategy for solving flowsheet simulations in ASPEN Plus is equation-oriented, or EO. EO gathers all model equations presenting the mathematical model of the whole system and solves them simultaneously. EO approach tends to convert processes with a large number of recycling loops much faster than SM. However, large effort is required to initialize an EO simulation. EO is very effective for the types of problems that SM is weak. For example, highly heat integrated processes or highly recycled processes or the process with many design specifications or process optimization problems. Here, there are some tips for practice using ASPEN Plus. Build a large process flowsheet with a few blocks. Also, start with simplicity and then add up complexity. For example, start building the flowsheet with the only major equipment and leave recycling loops to be the last thing to be added. Also, use reasonable flowsheet inputs, as well as be careful about units of measurement. And the last thing is that you need to always double check that the results are consistent and make sense.